Okay, hi, welcome everyone on YouTube. Welcome. Let me minimize this obvious thing. All right. Yeah, welcome everyone on YouTube to this video of OpenFoam Application Editing. So last video I actually went through some remarks about OpenFoam memory optimization and probably why you should not touch it if you're starting out on this OpenFoam Application Editing. Okay, so all right, we have been discussing lots of functions, a lot of classes, a lot of syntax and everything. So um, uh, let's get to a point where we can actually start playing with all this code. Okay, so my my aim is to just get us to play with the fvScalarMatrix class, and of course play with the fvScalarMatrix class and at least run a solve one of these solve functions. Okay, of course the syntax compared to what we were doing is quite simple, but okay, nevertheless it will need some demonstration first just to tie all the concepts together. Now how do we get started? All right, okay, how do we get started if we want to start playing around with fvMatrix? So first thing first, of course we go to backtrace our steps, right? So we see that this was where we demonstrated the TMP code in the IcoFoam, experimental IcoFoam, which is the Ico heat foam basically. So over here we see every scalar matrix is being declared. This is a type of finite volume matrix, as we saw in the last few video. T equation is being declared, and of course fvm ddt of the temperature field, something is being done to it. Okay, so what is this T? Now this T will actually be found in createFields.H. Okay, under createFields.H, T will be a volume scalar field. Okay, volume scalar field. Okay, and it will have this IO object. Okay, which is basically your input output object. What is the input output object dependent on, or what does it do? Okay, it helps to read your 0 directory, and then it reads the stuff off there. So you can see it here, IO object, the field name is T. It will be found inside runtime.timeName. Okay, runtime.timeName. Okay, so that what is runtime.timeName? Okay, under the time directory, basically every time you have a you have this runtime in time.h being declared. Time name is one of the functions that returns the time name, of course, which is, it could be the time of 0, it could be the time of 0.5, whatever time you are at, you need to keep reading back your temperature fields. Okay, so this is the part where we read the temperature fields at every single time step. Okay, of course you don't have to return the runtime time name. I think you can actually put 0 there, but of course we will need to test that out. Now next thing, these are the arguments that you give into this IO object, which is yet another function or whatever class that is being called. Okay, so I assume this will have yet another big set of code to go and look into. I'm not going to look into that yet. We'll just use the syntax as is and read as is. Okay. Okay. You'll see this thing called mesh here. Okay. This mesh. What's this talking about? Okay. So we have not quite talked about mesh just yet. Okay, and where this mesh object function or variable is being defined. Okay, well, if we take a look at runtime and we observe that createTime.H actually makes this object called runtime, we can also infer that object, and the object of mesh is being created elsewhere. Okay, so maybe later I'll get into this where this mesh thing comes from. Okay, then of course you have IO object must read and IO object auto write. Well, it just means you must read the file every time, and then auto write, that means it will write new temperature fields, you know, new T fields, right? T fields, new temperature fields every time. Okay, so and then of course the mesh thing is being given there. Okay, when you take a look at this, okay, you see this volume scalar field is the class, and you are declaring an object based on this class. Okay, and of course you give in some arguments. Okay, so what is this? This is actually going to call a constructor. Now remember, constructors are just functions that you run straight away when you declare an object. Okay, so you declare an object called based on the class volume scalar field. So you run the constructor volume scalar field. Well, what is volume scalar field? Volume scalar field is a type of geometric field, and it will use this constructor here in line about 392. Okay, line 392. Okay. Okay, now where is this line 392? Okay, you can take a look at the bottom right hand corner of Vim here. You will see as I go up and down, the numbers will change, meaning to say, yeah, this is line 392 where my cursor is right here. Okay, around line 392 is where you have the correct constructor, where this you give it two inputs. One is an IO object and the other is a mesh, and then you'll start constructing this geometric field, which is the more general class of the volume scalar field, as we discussed before. Okay, so two things are being given. One is the IO object, which is this IO object here, and the other thing is the mesh, which is this mesh object over here. Now, of course, there are a few things over here which you may or may not have seen before. Okay, you may or may not have seen before. One is this thing called constant. Okay, this constant. Constant, what does it mean? It means once you declare an object or variable, it can never change in the code. Okay, so it's a sort of modifier similar to inline. Okay, so again, I say again, once you declare this variable as constant, it will never change. Okay, so that's the rough concept of constant. So if you want to read this code and not get confused, just ignore this constant bit, but for the time being. But just so you know, this constant is here to say that, alright, you can never change these objects or these objects once they are defined. Okay, you cannot change the values, you cannot change anything in there. Yeah, or you cannot change what if I say the input output object is IO object, it will always be IO object and this specific set of object, this object with these functions and data and whatever. Okay, or if I say integer a is a we type constant integer a and then we declare that as 5. Like for example, I'll just say constant integer a equals 5. Okay, that means a will always be 5 and no other value. So that's what I'm doing over here. Okay, so now hopefully that clears things up. Okay, so two things here. One is the IO object being given, which is this part. Then this second part is of course a mesh. Okay, which is literally called mesh. So now good for them. They make it simple. Okay, the other feature you may not have seen before is this thing over here where I'm highlighting, where it says read all time. Okay, read all time. Why is there an equals true over here? Okay, so this actually gives the read all time is actually a boolean. A boolean, this bool over here is just a type of data. It's either a 0 or 1. Okay, it's either a 0 or 1 or on and off. Okay, so read all or true and false. In this case, is true and false. So read all time is a boolean which is given a default value of true. Okay, so what does this mean? Okay, usually in this constructor here, there is a third input called read all time, which is a boolean. Okay, so read all time. If you don't, normally in your constructor you must give 3 inputs. But if you don't give the third input here, for example, it will default to this value of true, and this is the default value of read all time. So if you don't specify read all time there, read all time will always be true. So this is a default value of input into a function. Okay, so this is a function, a special kind of function called constructor. It normally takes 3 inputs. One is the IO object, one is the mesh, and one is the read all time boolean. Okay, but in this case, in OpenFoam case, IcoFoam, IcoHeatFoam, or IcoHeatFoam, we only give 2 inputs. One is the IO object, one is a mesh. The IO stands for input output. Mesh is just a mesh. So 2 inputs are given. So these two are given, and the third input is if you don't give it, it will just you can specify a default value. So the third input given to it is this read all time equals true. Okay, but you don't have to specify it here because in this code here you already gave it at least OpenFoam already gave it a default value. Okay, so this is what the logic of declaring this volume scalar field is like. You go into this geometric field. Again, where is this geometric field? Okay, you can just pwd is in source OpenFoam fields, geometric field. Okay, okay, I won't paste again because I did have quite an extensive what do you call it? Yeah, quite an extensive explanation on where this geometric field actually comes from in the last few videos. So if you forget, just go and watch it. Right, so so probably after looking at this, there are 2 question marks in your head. What is this mesh and what is this IO object? Okay, so let's answer the second question. What is this mesh? Okay, so let's investigate what this mesh object is. Where will we find mesh object? Okay, you look at the IcoFoam file, you will see this thing called createTime, and then you'll see this thing called createMesh. Okay, so where is this createMesh given? Okay, createMesh. Where is this createMesh given? Okay, so if you're not sure, you can look for createMesh.H inside your source folder. So find dot name, then you look for create. All right, I'm supposed to put a dash name, createMesh.H. Where is it found? It's found in OpenFoam include createMesh.H. Okay, let me say again, OpenFoam include createMesh.H. Okay, so later, of course, this one I will kind of put it inside your inside the description of the video, so you can go and take a look in case you forget. So this is where your create mesh will be. So we can just do a simple vim of this. Okay, we can take the second one. So you just copy and paste. All right. So this is what the createMesh.H looks like. Okay, so this is a very big file here, as you can see. Lots of if and else cases, a lot of if and else, and you see this auto PTR being used here again. Now again, auto PTR is just another tool for memory management. Yeah, so you're sort of forced to you're forced into running using it now. Then you have this region name, okay, region name, which is your default region. Okay, and then you have a lot of if and else loops. Okay, so let's examine the if and else loops to trim down what we need to think about and what we don't. Okay, first thing is this thing called a dry run option. Okay, do you want to run a dry run? Dry run. Okay, so for OpenFoam allows you to specify a run as a dry run. That means I only run it for one time step and see what happens to see if there are problems. So this is the dry run part. Okay, so this thing is not really what we want to deal with yet. We just want to see where this mesh is created because you can't really see it from here. So if the dry run is not our concern, Then the next part is, what is it? The next case is this thing called dry run write. Again, we don't want to deal with this. Now, if you see over here, it actually takes this runtime thing. Okay, so do you want to write your mesh or don't know what thing? Okay, so you don't do anything with dry run write. It doesn't say where mesh is created. Then this one is else of that. It says it's a processing dry run. So this whole thing here is if you're talking about dry run. So you don't want to deal with dry run, just ignore this part of the code first. So this part of the code is more interesting if you're not dealing with dry run. Over here, the second part of code called in the createMesh.H file, located under OpenFoam include. Here is you want to see whether the region name is present. Okay, so this is usually for multi-region cases like CHT multi-region foam, conjugate heat transfer multi-region foam. Of course, we are not dealing with multi-region cases here, so we are not going to look at this. This is for multi-region cases because it looks for a region name. Okay, so this is the part. It says else info create mesh for time. Okay, so it will run this bit of code here under these parentheses, and then it will run this thing in the auto PTR. It says mesh pointer. PTR stands for pointer. Reset. Okay, what's a pointer? Pointer is basically something to deal with memory, and yeah, pointer is something to do with memory, and it's very similar to what memory management we are talking about. Okay, so in C++, this is somewhat of a slightly more advanced topic, but I did go through a little bit of pointers in my basic C++ for OpenFoam, but I'll just go through it again here. Let's say you have an integer a equals 5. Okay, how do you store this a equals to 5 value? You need to store it somewhere inside your memory. Okay, you need to store it somewhere inside your memory, usually your RAM or wherever else. Okay, so there's more than one kind of memory. RAM is just one of them. So the simplest way to explain it is that you can see that you can think of it as the a equals 5 value will be stored inside your computer's RAM. Okay, this is one sort of memory, one type of memory. So let's take, for example, a equals 5 is stored in the RAM. So the idea is that if you want to find this value a equals to 5, how does the code know where in the RAM it's being stored? Because sometimes your RAM is 4 GB at least, and nowadays this is very small. In 2021, usually computers are 8 or 16 or 12 GBs now of RAM. Okay, so there's 4 GB of space to look into. So how does how does C++ know where to look for it? So usually you don't just have a value of a equals to 5. You need to supply the code with something called an address. Now in Python and all that, when you code or in Python or MATLAB, you don't really have to care about all these address things. But when it comes to memory management, C++ does give you the option to handle all of these addresses. Okay, pointers, addresses. So a pointer, or this PTR, it will basically it's basically referring to this address to say, okay, where in this memory is this a equals to 5 located. Now this doesn't just apply to these integers. It will apply to scale whatever stuff in OpenFoam as well. For example, your mesh has to be stored inside your memory, right? So your mesh has to be stored inside your memory, and to deal with it, you need to have a pointer, right? A pointer for the mesh. So the mesh pointer will tell your code or tell your CPU, where is this mesh being created. Okay. So this is where we see the mesh coming in, and okay, this is where we see all the memory management things coming in. So normally speaking, we don't want to mess with this part. We don't want to mess too much with this part. What we are interested in is where is this where is what am I calling? Where is mesh being declared? Okay, where is mesh being declared? So you can see you will see this new foam fvMesh. Okay, there's a constructor being run. For fvMesh, the constructor of fvMesh is being run and constructed using an input-output object. Again, an IO object is used under the namespace foam. Okay, the region name you have to say. Okay, region name is, if you don't have any regions, it'll just be this default region. So don't touch these bits of code. You will be based on this runtime time name. Okay, runtime time name, and it will all be read on. You have to declare it under runtime. Okay, so yeah, basically, yeah, this runtime time name is usually you start from 0, and the runtime, yeah. Well, we will have to check the time.h. I can't remember it offhand now. But basically, the idea is that you must read this. You must read this the mesh, right? You must read this mesh. Okay, mesh object or whatever it is. Okay. So that's the idea here. Okay, so this is what createMesh.H here is. It has to read this input-output object from this time name. So it will start making your mesh, which you can then use this object, this mesh object, to put it into your T equation, which is T equation.H, which is over here. This createFields.H. Yeah, this mesh will be then used to make this volume scalar field. So you see mesh being used here 2 times, and you can see the keyword mesh is being declared here as, I think, an object. Okay, this mesh is being declared as an object, if I'm not wrong. Okay, using the mesh pointer, and of course this ampersand, this is called ampersand sign. So it's also, I think, to deal with pointers and addresses. So I won't go too much into detail. Maybe, yeah, not in this video anyway. So yeah, basically your mesh is declared here in createMesh.H. So of course, all of this requires a runtime thing, right? It requires this runtime, okay? Runtime, which means you need to set up your control dictionary and run your createTime.H script. So if you take a look at experimental icofoam.c, you will see often that createTime.H has to be run before createMesh.H, and createMesh.H will be run before createFields.H. So createMesh.H is this file over here. createTime.H is the prerequisite to that, where you can have this runtime object. createFields.H is where you start to read. Okay, you start to read all your dictionaries. For example, your transport properties or thermophysical properties, and then you also read your temperature objects. Okay, you create your temperature volume scalar field using the mesh object and the input output object, where you read your you know, yeah, you read your what do you call that? My mind's not working. Yeah, you read your temperature field. Okay, so I actually want to try and give us a way to start playing with this matrix classes without having to deal with runtime objects. So I probably want to change some of this, or at least import some of this into the what do you call that? The volume scalar field. No, into the sandbox file, and then we want to specify which folders we can read on the temperature files, which folders we can read our mesh files, and etc. etc. Okay. So yeah. Yeah, constant. Okay. So that's basically where we are trying to get headed. Okay, but of course we need to know what runtime timing is. Is it an integer object or a float or whatever? Okay, so let's if you want to play around with these objects, we have to without if you want to play around with these objects without yeah, if you want to play with these objects without, what am I going to say? My goodness, where did I hit it now? Without using the time createTime.H directory, so we need to understand what inputs are being given. Anyway, my mind's going off track already, as you can tell. I probably need to take a break and then before making another video. But thanks for watching. I'll see you again. Bye bye.